Hi, at WoolyAI, we are building the GPU Hypervisor technology to abstract the ML workload execution from the GPU infrastructure and enable users to maximize utilization of their GPUs, simplify operations, and scale across multiple vendor GPUs with no code changes. WoolyAI Hypervisor enables users to run their existing CUDA Pytorch or vLLM inside a Wooly unified Docker container image that executes CUDA kernels on both Nvidia and AMD without requiring any code, configuration, dependency, or toolchain changes. In this video, I will explain this feature and also show you a brief demo. The Wooly client container runs your Pytorch projects or inference apps like vLLM on any CPU-only node and sends CUDA kernels represented as Wooly instruction set to the GPU nodes running the Wooly hypervisor. On the GPU nodes, Wooly hypervisor just-in-time compiles them to the native Nvidia or AMD instructions with hardware-specific optimizations and executes them with the GPU native runtime libraries. With Wooly, you have one Docker machine learning container image and run your unmodified CUDA Pytorch workloads on Nvidia or AMD. The Wooly Docker client container includes Pytorch and other machine learning optimization libraries like Flash Attention, Bits, and Bytes, which are compiled with Wooly runtime libraries. Inside this container, Wooly runtime library converts CUDA kernel launches into a Wooly instruction set and sends it to the Wooly server running on the GPU nodes. On each GPU node, the Wooly server just-in-time compiles that Wooly instruction set to the native backend, CUDA on Nvidia and ROC-M on AMD, and the Wooly execution server runs it at near-native performance. Same container image works on both Nvidia and AMD GPU clusters, so teams keep a single golden environment and unlock available GPU capacity. Here are the key benefits of using unified machine learning containers that can execute on both Nvidia and AMD without any code changes. First, your machine learning engineers and researchers can without any code changes run the same CUDA Pytorch container on AMD or Nvidia GPUs. No need to worry about platform-specific runtime stack. Second, you can buy any GPU at the best price or availability and are not locked into Nvidia. Third, for platform and DevOps teams, there is only one golden image across Nvidia and AMD with no driver and runtime permutations. This makes CI/CD simpler. Fourth, you can eliminate vendor lock-in and achieve faster time to capacity without paying an engineering tax to port code. Now, let's jump into a short demo to show you how it works. Hi, I'm on a Nvidia GH 297GB of VRAM single GPU host. This is the WoolyAI unified Docker image. It's a base image for your ML containers and ships with Pytorch compiled against the Wooly runtime. Inside the container, there's a config file where I choose which GPU host executes the CUDA kernels. Right now, it points to this Nvidia machine. I'll run a sample Pytorch inference script that uses CUDA and calls llama13b in a loop, 20 prompts. The inference is now running on the Nvidia GPU. Now I'll open the same config and change the address to an AMD GPU host. You can see it now targets an AMD M3000 GPU host. The key point: researchers don't change their code or project settings. The exact CUDA Pytorch app runs in the same container on Nvidia or AMD, no making it compatible with HIP, no rebuilds, no changes in the toolchain. Let's run the same Pytorch CUDA script again. The ML container stays on this machine, but this time the CUDA kernels execute remotely on the AMD GPU. This is a single, unified container that can run ML workloads on both Nvidia and AMD GPUs without any modifications. You'll notice the response time is higher than the local Nvidia run. This is because my AMD host is in a different region, so network latency between the Nvidia and AMD hosts is contributing to the higher response time for the prompts. In a real enterprise setup, the GPU pools are located closer to the infrastructure where the unified container executes or are connected with very low network latency. The benefits of this feature are a single ML container image for both Nvidia and AMD with zero code changes. You reduce vendor lock-in, unlock capacity faster, and avoid the engineering tax of maintaining parallel stacks. Thank you for your time. For more information, visit WoolyAI.com.